Hi, this is Sarah. As I'm Ferry, I'm going to talk about question number one of homework three, course probability and stochastic processes course. Okay, in this question, we have a probability mass function and we have a parameter which is unknown to us. But as we know that this is a probability mass function, we know that the sigma of this from minus infinity to plus infinity should be equals to 1. But here we know that k starts from 1, so we should just start from k equals to 1 and have a sigma to infinity. Okay, let me go through my answer to this question and check check my answer. Okay, we write this formula and we write the sigma from k equals to 1 to plus infinity. And as I see, Uh, here we need some kinds of approximation to write the answer. Uh, and the approximation is this, that the sigma from n equals to 1 to infinity is uh, equal to this fraction. So I will exactly use this in my answer, and the whole term is equal. The whole term equals to 1. So now very easily we can find the value for parameter b. Okay, let's go to the next part. In the next part, which is part b, we want to calculate the expected value for x. And here is my answer for this question. And as you know, the expected value for a variable is calculated like this. We have the sigma again, and we need to calculate k times our probability mass function. And then after writing the formula for our probability mass function, we get to this. Again, we need, we get to this, and again, we need some kinds of approximation to write for this. But the the first approximation that we used, it's not enough because we need, because we have uh, k to the power of 2. So we should get the derivative of this formula. I have written it here in the bottom of the page, and the derivative, uh, we should take a derivative of both parts, and then we will get to this formula, which is exactly the same way that we need. And so again, we will substitute this formula, and then we can calculate our answer. In part C, we want to calculate the expected value for x to the power of 2. And here again, if we write down the formula, we need to we need k to the power of 2 times the probability mass function. And again, we have k to the power of 3 here. So what we do is the same as before. We get the derivative of our approximation, and we get to this formula. And fortunately, this formula is something that we want, except one thing, that here we have k to the power of 3, but here we have k to the power of 3 minus k to the power of 2. So we will change the shape of this formula, shape of what we have here, so we change the form so that we can use our approximations, and this new form is exactly what we had in the approximations. And we will write them down, and these two terms, we, we should plus these two terms, and then we will get to our answer easily. And for part D, let me check that my video is fine. Yes. For part D, uh, we have all the ingredients, so we can calculate this really easily. We have expected value for x to the power of 2, and we have expected value for x, and then expected value for x to the power of 2 is really simple. We just have to write down the expected value for x, and then we should make it to the power of 2, and after doing this calculation, we can get to our answer. And let's go to the last part of this question, which is part E. And we need to calculate the probability of x equals to k given x between 2 and 5. Okay, here this is a conditional probability, and we should write the formula that we have, which is probability of x equals to k and x between 2 and 5. Okay. Uh, If we put some conditions on k, we can simplify this formula. How? If k is between 2 and 5, we can simplify the formula like this. We can omit the second part, and we can write the probability of x equals to k. And if k is bigger than 5 or smaller than 2, and in this case, smaller than 2 means only k equals to 1, the probability is 0. And let's calculate the formula that we have here. So the probability of x equals to k divided by the probability of x between 2 and 5. Okay. The probability of x equals to k is simple because we have it from the formula, from the probability mass function. But let's go to the probability of x between 2 and 5. This is also simple because we should write it like this. Probability of x equals to 2 plus probability of x equals to 3 plus probability of x equals to 4 plus probability of x equals to 5. That's final. And then we can plus all these values and get to our answer. And now we have the denominator, and then we have the probability of x equals to k from the probability mass function, and everything is fine, and we have the answer. Okay, I think I answered this question, and thank you very much.